Somewhere beneath your street, a steel pipe carries oil, gas, or water, and almost nobody knows how it's born. This single piece of steel began as raw rock, torn from a mountain thousands of miles away. Most people never think about this. But pipelines are one of the most demanding products. Steel can become T has to survive crushing pressure, freezing cold, scorching heat, and decades buried without ever failing. Today, we're going inside the factory where ordinary rock becomes a backbone of modern civilization. And what happens inside these walls will change the way you see every pipeline you'll ever pass. But before any of that, we have to go back to where it all truly begins, the Earth itself. What you're about to see took millions of years to form, and less than a day to transform. It starts in places like the Pilbara in Australia, or the iron-rich hills of Brazil's Carajás mine. These mines pull out that's roughly 60% pure iron, buried under layers of ancient rock. Massive haul trucks, some carrying 400 tons, move the ore to crushing stations nearby. From there, the ore travels by rail, sometimes over 500 miles, to a waiting port. Here's what nobody tells you. One cargo ship can carry 200,000 tons of ore at once. That or crosses entire oceans, heading toward steel mills in China, India, or Europe. Once it arrives, the ore is crushed, screened, and blended with coking coal and limestone. That mixture is fed into a blast furnace, heated to nearly 1,500 degrees Celsius. Inside, chemical reactions strip away oxygen, leaving behind molten iron ready for the next stage. Imagine this. Every ton of steel starts by burning away nearly 30% impurities in minutes. The refined steel is cast into massive slabs, then rolled again and again into thin coils. This is where things get truly extraordinary. A slab thicker than a mattress becomes paper-thin steel. That thin steel is cooled, coiled, and shipped to the exact factory where our pipe is born. And here's the surprising part. The environmental cost is enormous, nearly 2 tons of CO2 per ton of steel. But what happens next inside the pipe mill itself will completely change how you see steel. The steel coil arrives and is uncoiled at nearly 2 meters per second onto the line. The edges are trimmed and cleaned, removing rust and scale before the steel meets the forming rolls. Now watch closely. A series of rollers slowly curls a flat strip into a perfect tube shape. The two edges meet, forming a seam that's about to be fused permanently by electricity. High-frequency electric current heats the seam to over 1,300 degrees Celsius in seconds. Pressure rollers squeeze the molten edges together instantly, fusing the pipe with no filler metal at all. A scarfing tool shaves of the excess bead, leaving the outer surface completely smooth and seamless looking. And here's what surprised even experienced engineers. The whole well happens in under half a second. The still-hot pipe now enters a sizing section, where rollers shape it to an exact diameter. Tolerances here are incredibly tight, often within half a millimeter of the target measurement. Next, the pipe is cut to length by a rotating blade, spinning at incredible speed. Then comes heat treatment. The pipe is heated again and rapidly cooled to strengthen its structure. Water-quenched jets cool it from 800 degrees to under 100 in mere seconds. This is where it gets truly extraordinary. That rapid cooling doubles the steel's internal strength. Every pipe then rolls toward a hydrostatic test station, where it's filled with water under massive pressure. Pressures can reach over 150 bar, enough to instantly reveal any hidden weakness. But here's the twist nobody expects. A single failed pipe here can never leave this factory. Before it even reaches hydrostatic testing, the weld seam faces something even more unforgiving: ultrasonic inspection. These sensors detect flaws smaller than a human hair, down to fractions of a millimeter that X-ray imaging systems then scan the weld, revealing internal defect invisible to the human eye. Out of every batch, rejection rates typically stay under 2%, a remarkable standard for heavy industry. A robotic arm with laser scanners that measures every pipe's roundness down to microns. AI-powered vision systems now scan every meter of surface, spotting scratches invisible to tired human eyes. Every pipe must meet international standards like API 5L before it's allowed to carry anything at all. Some pipes face destructive testing too, cut open, bent, and flattened just to prove their limits. But even with all this automation, one moment still depends entirely on human skill and instinct. An experienced inspector can feel a flaw the machines missed just from the texture under their fingertips. And what this inspector finds next will determine whether this exact pipe ever leaves a building. Every year, the world manufactures over 150 million tons of steel pipe and tube. That's a global market worth well over $120 billion every single year. China alone produces nearly half of the world's steel pipe, followed by India, Japan, and the United States. Together, these industries employ more than 2 million workers across mines, mills, and finishing plants. Pipe manufacturing has existed since the 1820s, but modern welding changed everything in the 1930s. Over the last 50 years, production speeds have increased nearly tenfold thanks to automation and robotics. And over the next decade, demand is expected to grow further, driven by hydrogen and renewable energy pipelines. Did you know a single large pipeline project can use enough steel to build 50 Eiffel Towers? Did you know the longest continuous pipeline in the world stretches over 4,000 kilometers? And did you know some pipes are engineered to last more than 100 years underground? The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards. That's not just a product. That's a masterpiece of human engineering, hidden in plain sight. If you want to go deeper into the hidden world of manufacturing, tell us in the comments. What product would you like us to explore next inside its own hidden factory world? Like this video, subscribe to the channel, and we'll see you inside the next factory.